So today we will learn about how to perform analysis in Etabs. So uh, this is G+15 building, and I will give you brief introduction about the building. And it is a commercial building. Okay, so you can see these are the shops, and actually it is a mall. Okay, and okay, so there is a lift and staircase and all. This is architecture drawing, and this is the framing we have prepared. And this is a section. So you can see this is the ground floor, and there are 15 floors. It's a G+15 building, and yeah, so we have prepared the DXF. Okay, so now we will import the DXF in the ETAB, and let's see how we will do it. So first we will open the ETAB. Okay, and mm, it will take some time. So we will go to the file, and we will go to the new model, and we will select this use built-in setting, and here we will select metric SI, and here we will select India, and here we will select Indian. Okay, and here we will select IS 800 2007, and it's a concrete design code. We will select IS 456 2000. Okay, and okay, and here we will select blank, and okay. Mm, 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 mm. Let's close the window. Let's close one window. Okay, and now what we will do, we will go to the file, and we'll go to import, and we will go to DXF file of flow plan. So now we will open the DXF, and open the DXF, and here in the beam area we will select the center line. 1 minute. So for that, what we have to do, we have to copy this DXF in the different file. So what we will do, uh, we will copy DXF, and we'll go to here, and we will paste this at this place. And what we will do, we will save the DXF. Please make sure here you are saving it as the DXF file, and go to course, and go to Naveen Suthar, and here we will save this file. Okay, and we will close this file. Okay, so let's go to file first, then we'll go to the import, and then we will go to uh, .dxf file of flow plan. And now we'll go to course, go to the Naveen Suthar, and this is the drawing one. We will open this drawing, and here in the beam we will take the center line. Okay, and let's select the story one, and here the DXF we will check it is in or it is in meter. So go to the dimension, and we will check the dimension, what dimension it is, and we'll zoom this. Okay, I think it is in Okay, so select the Okay, here we will select concrete beam, and here column properties, we will select column, concrete column, and deck, and okay. So let's save this building as G+15 commercial building, and save this. Uh, let's open the presentation. So we are doing the Etab analysis, okay, and so for that we have to go to, so now we will go to plan and we will go to the story one and apply, and you can see the DXF is imported, and we will check the dimension. So we'll go to the draw dimension line and we will check the dimension. So yeah, I think it is perfect, okay. And if you want to remove the dimension line, if you go to the set display option and then the dimension line and apply this and okay. Uh, so now we'll define the material property. So for that we have to go to the define, we'll go to the material and we will add the new material, and here we will select the concrete, that is M30, and okay, and okay. Now we will add a new material, that is of rebar, and here we will okay, okay, and we will add one more new material, that is of SE 500, okay, and okay, and okay. So we have added the material, define the material, that is concrete grade and the steel grade, and we will define the section properties of the beam. So for that we will to go to the we will go to for that we will go to define, and for the section property in the frame section, and we will go to, we will select the concrete beam and we will select the add copy of property, and here we will write the beam sizes, what are the beam sizes we have in the framing. So let's see the framing. So here you can see the beam sizes are 250 into 600, and here is 300 into 600, 200 into 600, 250 into 600, and there is a 750 to 600. So we will assign we will define the section properties of the beam. So it's 250 into 600, so that will be 250 and 600, and here the reinforcement, we will go to the reinforcement, and it should be beam, and longitudinal bar should be HYSD 500, and okay, and okay. So we will add a copy of property, and here we will write B 200 by 600. So let's write 200 by 600, and it should be 200, and okay, and again add copy of property, and it should be 300 by 600. So let's write 300 by 600, so it's 300, and okay, again add copy of property, and it's 750 by 600, so it is 750 by 600, so it's 750 by 600, and okay, okay, and okay. So now we will add the column properties. So for that we have to check the what are the column sizes we have. Okay, so for that we will go to the dimension and we will check the dimension of the column. It is 1000 and it is 500 into 1000. So we will go to the define. We'll go to the section property. Go to the frame section. We will select the concrete column and add copy of property. And here we will write C 500 by 1000, and it's a 500 by 1000. Okay, and we will modify the show rebar here, and it should be the design M30 design column, and it should be like HYSD 500, and here the number of the longitudinal bar along third face, it's a third direction face, so it should be 5, and it should be 10 if we are placing the bars at the 100 spacing. Okay, and okay, and okay. No, there are more sizes. So I think these sizes are different. You can see these. So you can see these sizes are different. So we'll check these sizes. It's 650 and it's 100. Okay, so we will add a copy of property and we will write C 650 into 100,000. Okay, 650 by 1000, and here we'll modify this, and let's take 6 here, and okay. So here you can see this is a different size of column. So we'll see what is the dimension of this column, and it's 350 by 100,000. Sorry. So we'll go to the define, we'll go to the section property, we'll go to the frame section, and we will add a copy of property, and it is 350 by 1000. So it is C 350 by 1000, and okay. So we'll go to the modify here, and we will take 3 here, and okay, and okay, and okay. So now what we will do? We have defined the beam section, we have defined the column section, now we will define the wall and slab section. So for that we will go to the define, then we will go to the wall section, and here we will select the add copy of property, and we will write the W 200, and it should be 200, and it should be M30, and okay, and okay. So here you can see all the walls are sizes of the 200. So if you go to the dimension, and if you will select these 2 points, here you can see it's 250. Okay, so it's 250, and I think it is also 250, or I think it is 300 maybe. Okay, it's 250. So all the wall sizes are 250. So what we will do, we will go to the define, go to the section property, we will go to the wall section, and we will go to the modify show property, and we will change the size. It should be 250. Okay, and now we will assign the slab sizes, define the slab sizes. So let's take 150, and then we will check in the analysis that we are doing right or not. So for define the slab properties, we'll go to the define, we'll go to the section property, we'll go to the slab section, and here we will select slab one, and we will go to the add copy of property, and here we will write as 150, and it should be 150, and okay. And for the stair slab, we will go to the add copy of property, and then we will write stair 150, and here should be 150, and for the stair slab you have to select the membrane, and okay, okay, and okay, okay. And so we have defined every section properties. Now we will assign the beam property. For that uh, we will select these beam first. So for that we will go to here, and we will select these beam, and we will go to the assign, go to the frame, we will go to the section property, It is 250 by 600. So 250 by 600 and apply this one. And you can see these all these beams are 300 by 600. So we will select all these beams by one, and we will assign the 300 by 600. Okay, and now you can see all these beams. No, okay. So okay, so here the beam sizes are different. So what we will do, we will select one by one. Okay, so it is 250 by 600. These beams are 200 by 600. Okay, so what we will do, we will assign all the beam 200 by 600, then we will change. Okay, so let's select this one and 200 by 600, apply it, and now we will change. So it is 250 by 600. So one by one. Okay, 250 by 600, apply it, and okay, it's 250 by 600. So it is 250 by 600 and apply, and yeah, I think it's 300. These four beams are 300 by 600. So these four beams are 300 by 600 and apply. Okay, it's 250 by 600. It is 250 by 600. It's 250 by 600 and apply. Okay, so I think that's great. Mhm. So if you want to see every point in this, so for that we have to go to the set display and go to the invisible and apply. So you can see we have every point, right? So now we will assign. So now we will draw the quick wall. Okay. So now we will quick draw column. Now we'll quick draw column. So you have to go to the quick draw, and we will select the sizes from here, and let's take one size first, and we will assign all the columns. So there is one. Okay, so these are the columns we will assign here. Okay, and okay, so what we will do, we will select all the columns. So for that we will go to the select object type, and the columns, select the columns, show selected objects only. We will select all the column, then show all, and then we will replicate control R, and we will pick the 2 points from here to here and apply. So we have assigned all the column here, and there are columns here also, like these three columns are here. So what we will do, we will go to this at this. So we will select one column, this column, then this and this. Okay, one column, this and this. And what we will do, we will replicate the column and pick 2 points here and apply. Okay, so and this column, we will replicate this column here and apply. And what we will do, we will replicate this column and apply. Okay, so we have assigned all the column. Now what we will do, we will change the sizes according to. So for that we will go to select an object type, and column, and select the column and show related objects only. So for that what we will do, these are the columns of 500 by 1000. So we'll select all the columns We'll go to the sign, we'll go to the frame, then section property. Okay, and then we will select 500 by 1000 and apply this. You can see the orientation of these columns is vertical. So what we will do, we will select again, and we will go to the sign, uh, and go to the frame, and then we will go to the local axis, and here we will rotate it by 90 degrees and apply, and okay. Okay, you can see the orientation has changed. And now we will go to the show and deform shape, and now what we will do, we will change the orientation of these four columns. You can see, okay, so there is no column in this middle. Okay, so we will delete this one. So we'll change the orientation of these columns, and I think these columns are of so we'll go to the sign and frame, and local axis and apply, and okay, and we'll go to the show and deform shape, and these it's 615 to 1000. So what we will do, these four columns are 615 to 1000, so I think we have to change the orientation of these column also. So sign, uh, frame, local axis and apply, and okay, and okay, and these columns are 615 to 1000. Okay, and this is 351, so it is 350, apply, and these columns are size of 500 by 1000. So we'll select these columns, and it is 500 by 1000, and apply, and close, and show all. Okay, so now we will draw the wall. Okay, so we will draw the walls. Okay, so now we will draw floors. Okay, so for if you want to draw floors, so for that, so first select the floor size, select the slab size, and it should be S150. Okay, so it should be deck 1, and we will draw one slab here. Okay, and then we will select all, uh, then we will select everything, and then we will go to divide shell, and here you should select cookie cut floor, and untick extend to frame and apply, and here you can see every slab uh, assigned draw automatically. Okay, you don't have to waste your time to draw every slab. Okay, and we have assigned beam property, we have draw, so now we will draw the wall. Okay, so for that we will go to this section, and here you can see these are the walls, and this wall one, and this, there is one wall here. So let's draw these walls. So okay, so for that, go to the quick draw walls, and so the wall size is 250, and we will draw the walls. Okay, and okay, so here are the points. Okay, so you can see these, we want these points, so we will go to the dimension, and we will select these points. Okay, and we will check, it is almost 6 meter. Okay, so what we will do, we want these points, so we will select the joint, and then we will replicate the joint, control, and at the 6 meter distance. You can see we have a point. Now we can draw a wall. Okay, and so here we want one point here. So to draw the walls, so you can see. So we will go to the dimension and we'll check the dimension. So it is 2 meter. Okay. So what we will do, we'll replicate the joint at distance 2 meter and apply. You can see we have now a joint to draw the walls. So we'll draw the walls here like this. Okay. So here you can see the walls dimensions are same at these locations. So what we can do, we can mirror this wall here. So for that we will go to the select, we'll go to the object type, then we will select the walls and show selected object only, and then we will select the walls and then show all, and then we will go to the then we will replicate these and we will go to the mirror and then we will select 2 points. Let's select these 2 points and apply. You can see the walls are here. Okay, now what we can do, we will select the wall and we will move the wall like control M. Okay, it is not, so we'll go to the move and we'll pick 2 points, like let's take these 2 points and apply. You can see every wall, you can see the wall is 0. So you can replicate the walls, you can mirror the walls. Okay, so here you can see, so we have to move this joint from here to here. You can see the framing, there are walls up to here. So for that what we can do, we have to go to the all story and we will select the joint. So you can see the two joints are selected. Okay, so it should be all story. Please make sure the all story is selected. If you select only one story here, okay, and if you go to the 3D and apply one story, okay, and if you only select one story and like this, so it is only one joint is selected. If you go to the 3D, so you can see there is only one joint selected. Okay, here. Okay, here is, so if you will move this joint, so there is only one point will be moved, that is of upper point. So please make sure the all story is selected. Select and you can move this now. Okay, so now we will assign the floors. So okay, so we will select all the floors and we will assign 150. Or what we can do, we can unselect the staircase walls, staircase slabs. So and now we'll assign the shell, that is slab, and it is 150. And now we will select these staircase slab and then we will assign this one. Okay, and we'll go to here and you can see. So now we will assign the load pattern. For that, we will go to the define, we will go to the load pattern, and here we will assign the load pattern. So SW modify, and the self multiplier should be 1 for SW, and then it should be finished. Then it should be sunken, then it should be wall, then it should be service, then it should be alive less than 3, and we will delete this one, and then it will be EQX, then it will be EQY, then it will be EQZ, then it will be WLX, and then it should be WLXY. So you can see, and we will go to the OK, and so we'll go to the define again, and we'll go to the load pattern. So in the EQ, it should be seismic, and it should be the Indian code, okay, 1890. So we'll modify this. Again, we will modify this one. It should be wind, and we will take the code of 875/2015. And okay, and now we will assign the P delta. So we will take a scale factor of 1.2 for dead load and zero point 0.5 for live load in the P delta. We will go to the P delta, and we will select the iterative based on load, and we will select 1.2 for all the dead load, and we'll select 0 0.5 for live load. Okay, and now we will select assign the mass source. So for that we will go to the define, then we will go to the mass source, and we will add copy of mass source. Here we will write dead load plus live load, and it should be vertical, and we will untick this one, and we will specify the load pattern, and for the dead load we will take multiplier 1, and for the less than life we will take multiplier of 0.25, and for the greater than we will take the multiplier of 0.5, and we will include the vertical mass because we will take the vertical earthquake in the consideration. If our building is in the zone 4 or 5, we will take the vertical earthquake. And okay, here please make sure the default mass source should be dead load plus live load vertical, and okay, and we have assigned, then we will assign the floor load, that is dead load. So for that we will go to, so the dead load calculation. So for the general slab, for slab it is 1.3. So we will take 1.5. So we will select all the slabs and let's unselect the staircase slabs and we'll go to the sign, shall load uniform, and it should be in the finish it should be 1.5 and apply. And for the sunken slab it should be 3.175. So for the sunken slab, so you can see in the architectural drawing, so there is sunken above the toilet area. Okay, so here we will add the sunken load. So that will be 3.175. We will take it 3.5. We'll apply assign this assign shall load uniform, and in the sunken we will assign 3.5 and apply and OK. And for the staircase slab, the dead load should be 3. So we'll select the staircase slab and we'll assign. We'll go to the shell load uniform, and in the finish it should be 3 and apply and OK. Okay, so you can see there are the cutouts. So we'll delete the slabs here. Okay, so we will delete the slabs here. Okay, and here. Okay, and you can see there are the cutout also. So we will delete these slabs also. Okay, 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 okay. Okay, so these two slabs we will delete. Okay, we will delete these two slabs. Okay. So we have assigned the floor finish, we have assigned the sunken load. Now we will assign the lift machine load and the overhead water tank. So for that we have to go to the define. So we go to the edit and we will add the stories and we'll go to the modifier. Here it should be first floor and it should be second floor. It should be three floor. It should be four floor. Okay, and so the distance from base to first floor should be 2 meter, and you can see in the section. So the distance between ground floor and first floor it is 1 minute. It should be ground floor. Okay, and then it will be one first floor. And it is second floor and it is third floor. So distance between uh, base to ground floor should be 2 meter, and then from ground floor to first floor it is 4.05. 4.05 plus 0.6, and for it is for first floor to second floor 3.45, and now again it is 4.05. Okay, and we will add stories. So there are only 3 floors. So in the building there are almost 15 floors. Okay, and so we will add more floor number of stories in this. So let's add like uh, 3, 12, 12, 13. 14. So let's add 14 stories and okay. So here you can see we will write four floor, then 5 floor, then 6 floor, then 7 floor, then 8 floor, 9 floor, 10 floor, 11 floor, 12 floor, 13 floor, 14 floor, 15 floor, then it will be terrace and then it should be Mumty. Okay. So third floor to fourth floor it is 4.05 and it's 3.9. Okay, then sixth floor is 3.15. It's 3.45 and it is 3.45. Okay, then it is 3.45. Then 10th floor is 3.45. 11 is 3.45. 3.45. And the terrace floor it is 3.15 and Mumty is 3 meter and okay. And okay. So now we will go to the plan and we will go to the ground floor and apply. Okay. And what we will do, we will select everything and we will replicate this and we will go to the story and we will select first floor to terrace only and then we'll apply this and okay. So you can see in the 3D. So we are our building is ready. So what we will do, we'll go to the ground floor and we will delete every floors at the ground floor. For that we will go to the select, we'll go to the object type, go to the floors, select the floors, show selected object only, and we will select. So here you have to make sure that the all story it should be one story, and we will select every shells. You can see the 24 shells are selected at the left bottom, and we'll read this and we'll go to the show all and we'll go to 3D. You can see at the ground floor the slabs, we won't take any slab in the design. Okay, so now we'll go to the terrace and so for the empty area what we will do, we will select this area and we will select this area and we will replicate this area at the empty level and apply and okay. You can see, so this area is at the empty level. Okay, and we will go to the edit, and then we'll go to the edit story, and at the modify we will add one more, and it should be overhead water tank top. Okay, and okay. So now we will go to the plan, we will go to the mumty, so we will delete this one. Okay, so so what we will do, we will replicate this area at the mumty level also for the left machine room. Okay, so what we will do, we will copy this one, we will select this one. Okay, this area, and we will replicate the area at mumty level, and okay. Okay, 1 minute. So we will select, we have to select the whole area, I think. Okay, and replicate this area at the mumty level. And now we will draw the slabs at the mumty level. So for that, we will go to the, and then we will select the S150, and we have to draw one by one. So we will draw the slabs. Okay, so now we will add the lift machine load and the overhead water tank load. Okay, so for that, okay, so we will select the lift machine slabs. Okay, and we will assign, we will go to the assign, then we will go to the shell load, uniform load. So we will, and then we'll go to the service, and we will take it as we will take it 10 kilometer per meter square, and we will apply this, and we will select these mumty slabs and go to the assign, then we'll go to the shell load, and we'll go to the uniform, and we will take it as a 20 kilometer per meter square, and we will apply this one. Okay, and yeah, and then we will assign the floor live load. So for that, we have to go to the plan, and we'll go to the, so we will select, first we will select every floor, every slab. We will select the every slab, and we'll go to the assign, and we will go to the shell load, and so this building is a commercial building, so we have to take live load 4. So we will assign the live load, and it should be in the live greater than 3, and we will take it as a 4 and apply, and okay. And at the terrace level, we'll go to the terrace level, and we will select every floor at the terrace level. So we will go to the select object type floor, select the floor, show the right objects only. We will select the terrace floor and we will assign the live load uniform. It should be less than 3 and it should be 1.5 at the terrace level, and the show all. Okay, and okay, so now we will assign the wall load on the beam. So for that, I think every wall is 150 meter. So let's check the dimension first. Yeah, it's 200 mm. Okay. So for that, what we have to do, we will go to the wall load, and it is 200 wall thickness, and the beam depth is beam depth is 600. So we will check. We will select the beam depth is 600. Okay, and the floor height is maximum is 4.05. So we will take maximum. Okay, 4.05. So it is 15.54. Okay, so we'll go to this one. We'll go to the apply, and then we will select plan. We'll go to the plan, then we'll go to the ground floor, and here it should be all story. Okay, and we will select the walls location. So here you can see there are walls at everywhere and not at these locations. So for that we will select all the beams here. So for that we will go to the select, go to the object type, then we will select the beams only here, and the show selected objects only, and we will select all the beams. Okay, and here you can see we will there is no wall load here, so we will untick this, unselect these beams from here to here and these beams. Okay, and we will assign and go to the frame load and distributed and wall, and it should be 15.54 and apply, and okay. Okay, there is no wall load here also. So if you go to the display, the load assign frame, and you go to the wall and apply, so there is no wall load here. Okay, so we will select these frames and we'll go to the assign and the frame load and the distributed, and we can delete the existing load here. So you can see there is no wall load here. So now we'll go to the terrace, and so now the show undeformed shape, and here we will go to the one story, and we will select every beam here, and we will go to the assign, and then we'll go to the shell load, go to the uniform, and we will delete the load, and then we will select the periphery beams for the parapet wall load. Okay, so parapet is 200 thickness, so it should be 5.4. Okay, so we'll assign and we will go to the frame load and we'll go to the distributed load, and it should be 5.4. 4. So it should be 5.4. So, okay, I think we have to delete these loads. I'll go to the assign, we'll go to the frame load, go to the distributed. This is a wall load and we'll delete this one. Okay. Okay. So now we will assign the stiffness modifier. Okay. So go to the show all object and go to the show undeformed shape. Okay. And here we'll go to the select and we'll select the object type and we'll select the wall, assign the stiffness modifier. Then we'll go to the assign, then we'll go to the shell, then we'll go to the stiffness modifier, and in the in plane it is 0.7 and at out of plane it is 0.1 and apply and OK. And now we'll select the beams and then we will go to the frame property modifier and at the it should be 0.35 and we will take 0.01 in the torsion and apply and OK. And we will select the column, we will select object type and we will select the every column and we will go to the assign, the frame load, the distributed and no, we'll go to the assign, then we'll go to the frame, then the stiffness modifiers, property modifiers and it should be 0.7 and apply. And then we will select the slab, then we will select the object type and floors and we'll select the every floor and go to the assign, shell, stiffness modifiers and in the out of plane it should be 0.25. Okay and apply and okay. Now we will assign the end release. So for that we'll go to the plan and we will select all story here. Okay. So here we will assign the end release. Go to the assign frame release and we'll select this one and apply. And we will select these beams here and we will assign the end release. And these beam also gonna assign the end release. And these beams also will assign the end release. So now we will merge the divided frames. So, there, I think every frames are merged here. You can see there is no divided frames here, right? I think it should be divided here. Okay, and yeah, it should also be divided here. Mhm. Okay, so we will assign the slab diagram. So for that, we will go to select. We will go to now, and we will select every floor slabs, and we will go to the assign. Then we will go to the shell, and then we will assign the slab diagram, and so we will select the D1 and apply. And we will go to the mum-t. Okay, so what we will do, we'll go to the select. We will go to the stories, and we will select these two stories, and we will select the story, and we will go to the assign, go to shell, and the diaphragm, and we will assign none diaphragm. And now what we will do, so it should be one story here, and we will select. Okay, so we will select these slabs. So for that, we will go to the select object type, and we will select the flows, show selected object only, and we will select the frames, shells only, and we will assign the shell diaphragm, and that it should be D1 here, and apply. We will select this slab and this slab, and we will modify it, and we will add a new diaphragm that is of D2, and OK, and we will select, and we will assign the D2 here, and you can see. Sure, now the diaphragm is assigned at every floor. And now we will assign the auto mesh to the floor and wall. For that, we will go to select. We will go to and we will select the floor walls first, and we will assign and go to the shell. Then we'll go to the uh, wall auto mesh, and we will select this rectangular mesh, and we'll apply this. And then we will select the floors. We will select the floors and go to the assign. Then we will go to the shell. Then we will go to the floor auto mesh, and then we will select the auto quick cut, and we will select this, and then we will assign 1 meter mesh, and OK. And now, so we will add the response spectrum analysis like spec X, Y, or Z. So for that, we'll go to the define, we'll go to the load cases, and here we will add a new case. So here it should be response spectrum, and we will write spec X. Okay, and we will add, and we will, okay. So before that, we will go to define, we will add function, and we will select the 1893, and we will add a new function, and OK, and OK. So yeah, so first we will modify the earthquake load and the wind load. So for that, we will go to the define, and we will go to the load pattern. Okay, and then we'll go to the EQX, and we will modify the lateral load. So we will untick everything, and we will take the X direction eccentricity, and then here we will select the terrace one from the base, and the response reduction factor should be 5. Okay, so we'll check the response reduction factor. So we will open the code. We will go to the codes here, and we will find the 1893. We will open the code. So here you can see. So our framing is dual system. Okay, there are columns and walls both. Okay, and the building with the ductile RC structural walls with RCSMRF. So we will take it as a 5. Okay, the response reduction factor should be 5. Okay, the response reduction factor R. And this building is situated in Delhi. So we will control F. We will write and we will just simply search Delhi. So you can see. So it is in zone 4. So it should be 0.24. Okay, and importance factor it should be 1.5 because so we will search importance. So this building is a shopping mall. You can see we will take 1.5 importance factor in this. Okay, and so we will calculate the time period. For the time period, we will take this formula. It's a 0.09 h divided by under root d. So we will calculate the time period. Okay, so let's open the calculator. First, we will see the dimension of the building in x and y direction. For that, we will draw the dimension line, and it should be like center of column to center of column. It's 48.72 in x direction, and it's a 17.275 in y direction. And then we'll go to the define, then we'll go to the load pattern, and we will select the x and modify the lateral load. And yeah, so let's calculate first. Okay, so we will check the height of the building. So we'll go to the plan, we'll go to the terrace, and it is 59.3. And the x direction dimension is 48.72. And it is y direction, it is 17.275. So you can, so these stacks are very small, so you can increase these stacks also. So let's 15, take 15 and 15. and okay. So you can see this is 17.275. So we will calculate tx and ty. So for that we will go to the calculator. So we have calculate the time period in x and y direction. Now we'll go to the define and go to the load pattern, and we will modify the EQX, and it should be 0.765. Okay, and okay. So we'll modify the EQY, and we will untick everything, and we will take the y direction by centricity, and we will select the terrace here, and we will select 5 here. It should be 0.24. It should be 1.5, and the time period should be 1.285. And okay, and EQ Z, it should be untick everything, just take x direction, and just terrace 5, this one 1.5 here, and it should be 0.4. And okay, and then we will open the W. We will modify the wind load, modify the lateral load, and here, so the daily wind speed is 50, and daily terrain category is 3, and importance factor is 1, risk coefficient is 1, and topography factor is 1. And now here we will select the ground floor, and here we will select the top story, and we will include the parapet wall of 1.2 meter. Okay, so for the windward and the leeward coefficient, here we will use the force coefficient method. Okay, so for that we have to go to the 875 part 3. So here we will select, so here we will calculate the force coefficient as per the figure 4. Okay, this dimension is 17.275, and this dimension is 48.72. Okay, and the height of the building is 59.3. Okay. Okay, so if wind is in the x direction, so if wind is in the x direction, this is B and this is A. Okay, so this will be B and this is A. Okay, and the H and A is this one. Okay, So H is 59.3 and A is 40.72. Okay. So we will calculate the A by B and H by B. So A is 48.72. So 48.72 divided by B is 17.275. So it is 2.82. So it is 2.82 here. Okay. And now we will calculate H by B. So H is a 59.3 divided by B is 17.275. Is 3.45, 435, 432. It is H by B. So A by B is 2.82. So 2.82 here, and H by B is 3.432. So here you can see 3 is this. So we will go from here, and so it should, we can take it as 1.05. Okay, so let's take it 1.05. Let's take it 1.1. And for the y direction, same. So everything will be changed. A will, for the y direction, it will be like this. Suppose the wind is in the y direction, so it will become A and it will become B. Okay, now it is 70, 275. Okay, so now we will calculate A by B. A, it is 17.275 divided by 48.72, 0.355, and H by B it is 59.3 divided by 17.275. It is 3.43. Okay, no, H by B is different. Sorry. H by B will be 59.3 divided by 48.72. Okay, it's 1.2. 1.2. Okay, so now we will go to the A by B, that is 0.35, and H by B is 1.22. So we can take it as like 1.25. So let's take it 1.25 and okay, and okay. So we have modified the electric load and the wind load. Okay, and now we'll go to the response spectrum analysis. So to do the response spectrum analysis, we have to go to the define, we go to the function response spectrum, and now we will go to the like we will select the IS 1890-2016. We will add a new function, and we will select the seismic zone 4, and it should be 1.5, should be 5, and here we will select, we will write IS 1893, and okay. And now we will again select a new function, and we will write IS 1893 V, and we will select 4, and it should be 1.5, it's 5, and now we will convert to user define, and we will delete everything, and here it's 0, and it should be 2.5 acceleration. We'll modify this one, and it should be 2.5 acceleration. We'll modify this one. So we will take 0 to 10, it's 2.5 acceleration, and okay, and we will delete the extra one, and okay. And now we'll go to the define, we'll go to the load cases, and we will add a new case, that is spec x. Let's add a new case, the load case, and now we will write a spec x here, and we will select the response spectrum analysis here, and we will add a new acceleration. It should be 1893, and okay. Now we will add a new case again. Okay, we will add a copy of case. Okay, now okay, and now we will write spec y, and we will select u2 acceleration, and okay. Now we will add a copy of case, and we will select spec z here, and we will select vertical earthquake here, and okay, and okay. So now we will add the load define cases, the define load combination. Now we will add the load combination. So for that we have to go to the define, we'll go to the load combination. So okay, let's add a new load combination, name is Navi. Okay, and okay. Okay, and now save this file. So let's save this file, and save this file. To add the load combination, we will go to the file location, and we will open the, it's a $et file. Okay, and now we will like find the load combination here, and you can see there is a load combination name is Navi. So what we will do, we will go to the another model, in which we will copy the load combination, and you can see there are all the load combination. We will copy all the load combination, and we will paste here. And we will save the load combination, and okay. And now again we will go to the, we will open the Etab, Uh, we will go to the file, then we will import the file. It's etab.e2k text file, and now we will open the newly added model. So if you go to the define and if you go to the load combination, you can see all the load combinations are already added in the model. Okay.